Hello everyone. Today we'll be starting with probability. Now probability just means chance. What is the chance of something happening? So if I say what is the chance of it raining, we say the probability of it raining. So this example itself is something where we deal with probability in daily life. Every day in the newspaper, we get the weather forecast and it is usually written chance of rain 30%, 50%, 70%, so on and so forth, which just means there's a 30% chance of it raining, 50% chance, 70% chance. Probability is exactly the same thing. Just instead of the word chance, we use the word probability. Now in class 10, we will be focusing on events that are simple, that either something can happen or something cannot happen. And if there are many options, all options will have the same chance of happening. So for example, flipping of a coin, throwing of a dice, choosing a card at random from a pack of cards, picking something out of a box of many things. These all have simple, equal probabilities for all the cases in their particular situation. So let's first look at the definition of probability and then how it can be applied. So probability is defined as the total number of favorable outcomes divided by the total number of outcomes, which simply means if we have an experiment or an activity which can have multiple different results, the total number of results is counted, which is your total outcomes, and the results that you want are your favorable outcomes. So let's take an example where you are playing a game of Ludo. You need to throw a dice and you need to get 2 on the dice to win the game. So we know it's a simple dice. It can have 1, 2, 3, 4, 5, 6 as its various outcomes. So how many total outcomes do I have? 6. 1, 2, 3, 4, 5, 6. And what is my favorable outcome? What do I want to throw? I want to throw 2. So the probability of my event E, which is throwing 2, will be 2, or the throwing 2, which means only one event, so 1 divided by all of my possible outcomes, 1, 2, 3, 4, 5, 6, total 6. 1 divided by 6 is the probability of throwing 2. This is especially important because these are equally likely events. That is why we can do this. Otherwise, next year in class 11, you'll study when the events are not equally likely, then what will happen. But you don't need to worry about that right now in 10th. We will focus on equally likely events. Some very simple properties of probability are that 1, the probability can never be greater than 1, nor can it be less than 0. So we write this as 0 less than or equal to probability of an event less than or equal to 1. When the probability of an event is 1, we say that it is a sure event. It has to happen, because that just means your total number of favorable outcomes is equal to your total number of outcomes. So it has to happen. And if the probability is 0, that means it is an impossible event. Cannot happen. Only way for probability to be 0 is if your favorable outcomes is 0, which means no outcome exists that can happen. So probability of 1, sure event, probability of 0, impossible event. Finally, if the probability of an event happening, let's say PE, is any value between 0 and 1, the probability of event E not happening represented as P of not E or P of E with a bar on top or P of E with a dash or an apostrophe is nothing but P probability of not event is 1 minus probability of event. Because if you think about it, if the chance of rain is 30% or 0.3, then the chance of it not raining is 70%. It can either rain or not rain, which is 1 minus 0.3, 0.7. So these are just some basic simple properties. You can get some theory-based questions on them. Just remember them and then apply them as and when the situation arises. Now let's get into some special type of problems that we will face this year. So let's get started with some of the common problems that you will face in this year's syllabus. The simplest type of question is you have a bag of balls. There are 10 red balls in it and there are 5 black balls in it. You take one ball out of the bag without looking at random. We want to find the probability that it is a red ball on the probability that it is a black ball. So by our formula, total number of favorable outcomes divided by total number of outcomes. If I want to find the probability of red, how many favorable outcomes are there? 10. There are 10 red balls. So any of these 10 is a favorable outcome. How many are the total outcomes? Total number of balls that I can draw, 10 plus 5, 15. So the probability of drawing a red ball is 10 by 15 or 2 by 3. Similarly, number of favorable events for drawing a black ball are 5. Total number of events is still 15, the total number of balls. So probability of black is 5 divided by 15 or 1 by 3. We can see here there are only 2 events, drawing a black ball or drawing a red ball. So a different way of saying draw a black ball is don't draw a red ball, or in other words, probability of not red. And we know probability of not an event is 1 minus probability of the event. So probability of not red, 1 minus probability of red, which is 1 minus 2 by 3, 1 by 3. So this is where you can see how our properties are useful and where they can be used. Another common type of question relies on flipping of coins. Now, in the very simple case, if I flip a coin one time, this is a normal coin, I can get either heads or tails. Total events 2, probability of heads 1 by 2, probability of tails 1 by 2. This is relatively straightforward. What about if I flip 2 coins? Now let's try to picture what can happen. Either both coins will be tails, or both coins can be heads, or one coin can be tails and one coin can be heads, which leads us to believe that there are 3 cases: tail tail, tail or head, and head head. However, if you analyze the situation carefully, I can get tails on the first coin and heads in the second coin, or heads on the first coin and tails on the second coin. So there are actually 4 outcomes: tail tail, tail head, head tail, and head head. In this way, we can see that the probabilities will change based on what you are asked. So if someone says, what is the probability of getting both tails? Number of favorable outcomes, 1. Total number of outcomes is 4, not 3. because tail head and head tail are two different events. The order of it does matter in this case. So probability of two tails, 1 by 4. Probability of two heads, also 1 by 4. And now we come to the important part, which is wording in probability. If I say, find the probability of getting exactly one tail. Exactly one tail means not 0 tails, not 2 tails, exactly one tail. So what are the situations that satisfy this? Tail head and head tail. Two such cases. So probability of exactly one tail will be 2 by 4. Probability of at least one tail. At least one tail says either one tail at the minimum. So that means one tail or two tails both satisfy this case. So tail tail, tail head, head tail. 3 out of 4. So probability 3 by 4. Probability of at most one tail. At most means not more than one. So that means either 0 tails or one tail. Tail tail will not be there. Tail head, head tail, and head head, because head head has 0 tails. So again 3 by 4. Like this, if I flip 3 coins, these are all my possible outcomes because the order matters. So whether it's 3 heads, 3 tails, 2 heads, 1 tail, or 2 tails, 1 head, I get 8 total outcomes. So just like we did these questions, focus on the wording and then calculate your likely events and what you want. From that, you can calculate the probability in the same way. So we already saw what probability is like for throwing one dice. But just like with the coins example, I can throw more than one dice. In fact, when playing a game like Ludo or Snakes and Ladders or any other board game, we normally throw 2 dice. So once again, 1 and 6 is different to 6 and 1. Now, the total number of outcomes for throwing 2 dice is actually 36. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. All outcomes when first dice shows 1. It will be the same for if I throw the first dice as 2, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Like this for 3, 4, 5 and 6. So 6 into 6, 36 total outcomes. Just like for the coins, questions will be phrased in a particular way. You have to understand it and visualize all of your desired outcomes. So if I say probability of throwing exactly 1 4. So this can mean 4 1, 4 2, 4 3, not 4 4 because that is 2 4s, 4 5 and 4 6. But also 4 on the second dice, 1 4, 2 4, 3 4, again not 4 4 because that's 2 4s. Also, if we had already considered it, we won't consider it again. 5 4 and 6 4. So we can see there are exactly 10 such outcomes where we throw only 1 4. So probability will be 10 divided by total outcomes 36. Just like this, they will specify various things. Probability of throwing at least 4 on the first dice means we don't care about the second dice. So if the first dice is 4, there are total 6 outcomes. 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. We said at least 4. Throwing 5 on the first dice, throwing 6 on the first dice. Total 18 cases where we have at least 4 on the first dice. Total number of cases again remains 36, 18 upon 36, 1 by 2. One special word that is used is the word doublet. A doublet just means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 such cases. So there are 6 doublets when I throw 2 dice. Finally, sometimes they don't ask you about the throw itself. They might ask you the total of the throw. Again, for Ludo and Snakes and Ladders, we move by the total of the dice. Now, if I throw 2 and 5, I will move by 7 places, not by 2 or 5. So they can say how many cases or what is the probability of throwing a sum of 9. So if I have 1 on either of my 2 dice, I can't get 9, I would need 8 with it. Similarly, if I throw 2, won't work. If I throw 3, the other dice can be 6. So 3, 6 or 6, 3, depending on first dice and second dice, 2 cases. 4, 5 and 5, 4, another 2 cases, 4. Now next would be 5, 4 and 4, 5, but we've already considered that. So we're done with our cases. So 4 cases where the sum is 9. Probability 9, 4 by 36, 1 by 9. So like this, whenever you get the 2 dice case, write out all your outcomes in this particular order in the same way that we have done it. Then simply see what is the question asking, find all of those cases and then calculate your probability. Next, we'll look at questions relating to a pack of playing cards. Now, if you're not familiar with it, a pack of cards consists of 4 suits or colors, namely spades, clubs, diamonds, and hearts. Each suit has 13 cards, starting from 2, 3, all the way till 10, and then 3 cards known as face cards, Jack, Queen, King, and then finally Ace, which is not a face card. So to repeat, 4 suits, each suit has 13 cards, from 2 to 10, 9 numbered cards, Jack, Queen, King, 3 face cards and 1 ace. So in a deck of playing cards, there are a total of 52 cards. Just like we've been doing till now, questions will be like, you draw a card at random. What is the probability of getting a king? How many kings are there? 4. King of spades, king of clubs, king of diamonds, king of hearts. 4 such cases, total cases 52, so 4 upon 52. Similarly, you may have noticed spades and clubs have been shown in black, whereas diamonds and hearts have been shown as red. This is because spades and clubs are called black suits or black cards, and diamond and hearts are called red cards or red suits. So a question can be, what is the probability of drawing a red face card? Condition number 1 should be red, diamond or heart. Condition number 2 should be a face card. So either Jack, Queen, King of diamond or Jack, Queen, King of hearts. Total such cards 6. So probability will be 6 upon 52. Like this, you can have any number of questions. All you need to do is be aware of what is in a pack of cards, what are your suits, what are the colors, what is a face card, number card, ace. One special type of problem is, if I pick a card and don't put it back in, now there will be 51 cards left. So depending on the card I take out, our total number of cards will change and our possible outcomes will change. For example, I tell you I took a king out of my pack of cards. So now there are 51 cards left and only 3 kings left. So if I want to find the probability of drawing a king now, it will be 3 upon 51 because 1 king has gone away and total number of cards is also reduced by 1. So like this, write out all your cases, see what the total probability is, total outcomes upon total, favorable outcomes upon total outcomes, and from that you can calculate probability when it comes to playing cards. For this final question, we first need to understand the concept of a leap year and a non-leap year. A non-leap year is what your regular years are like. There are 365 days in a non-leap year. This is any year that's not a multiple of 4. So like 2017 was a non-leap year. 2015 was a non-leap year. 2018, 2019, these are all non-leap years. A leap year is a year that is a multiple of 4, 2016, 2020, and in a leap year you have 366 days. So keep these things in mind for this next question. So we are asked, what is the probability that a non-leap year has 53 Mondays? So let's understand this question and how to approach it. Now, we know that 1 week has 7 days. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So let us assume that a year starts on Monday. After the first week, 7 days have passed. After the second week, 14 days have passed, and we've had exactly 2 of each day, 2 Mondays, 2 Tuesdays, till 2 Sundays. Like this, 52 weeks will pass. 52 into 7 is 364. So 364 days have finished after 52 weeks, meaning 52 Mondays, 52 Tuesdays, Wednesdays, Thursdays, Fridays, Saturdays, Sunday. Each day has occurred 52 times. 52 weeks have finished, 364 days have finished. But there are 365 days. So one more day, which if the first day of the year was Monday, as in the first week started on Monday, obviously that means the 52nd week would end on a Sunday. So the next day would be Monday. So the 365th day would be Monday, which would be the 53rd Monday of the year. So if my year started on Monday, the 365th day was also Monday, making 53 Mondays. However, if the year started on Tuesday, then the 365th day would be a Tuesday. So we would have 53 Tuesdays instead of 53 Mondays. Like this, if the year starts on Wednesday, 53 Wednesdays, Thursday, Friday, Saturday, Sunday. So the year can start on any one of 7 days, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. 7 outcomes, year starting on any one of these days. Successful outcome is if the year starts on Monday. If the year starts on Monday, I get 53 Mondays. So probability of a non-leap year having 53 Mondays is 1 upon 7. The year it starts on Monday versus all possible starts. So now let's look at the same question, 53 Mondays, except for a leap year. So let's take the same example. The year starts on Monday. So we will have 52 weeks passing, ending on a Sunday, 52 of every day. Now, the next day, the 365th day, will also be a Monday, 53 Mondays. But there is also a 366th day, which in this case will be a Tuesday. So not only do I have 53 Mondays, I also have 53 Tuesdays. So when a year starts on Monday in a leap year, I get 53 Mondays and 53 Tuesdays. Similarly, if a year would start on Tuesday, I would get 53 Tuesdays and 53 Wednesdays. The year started on Wednesday, 53 Wednesdays, 53 Thursdays. So on and so forth. Thursday will give you Thursday, Friday 53. Friday start will give you Friday, Saturday 53. Saturday start will give you Saturday, Sunday 53. And Sunday start will give you Sunday, Monday 53. So we can see again, the year has to start on either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Starts on Monday, I get 53 Mondays and 53 Tuesdays. Starts on Tuesday, Tuesday, Wednesday. Like this for all the cases. So on what days when the year starts do I get 53 Mondays? Obviously for when it starts on a Monday, but also for when it starts on a Sunday, because 52 weeks will end Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. 365th day will be a Sunday, 366th day will be a Monday. So now if my year starts on Monday or on Sunday, I get 53 Mondays. 2 outcomes that we want. Total outcomes are still 7 days the year can start. So probability of 53 Mondays in a leap year is 2 upon 7. So again, probability, visualizing all our possible cases, what happens in every single case. This is one of the harder questions of this year's syllabus, but it is important to understand and it is very useful for getting an idea of visualizing things. So these are primarily the types of problems you will be faced with. Other problems will be straightforward in the sense you will clearly be given the outcomes and you will be asked a particular probability. Just follow the simple formula, favorable outcomes divided by total outcomes. And with that, we can finish with probability.